Hi, I'm Brent Johnson, and today we are in Stowe, Pennsylvania, in the organ shop of Patrick J. Murphy and Associates. This is Pat Murphy. He is the owner, organ builder, proprietor of this company. Pat, how long have you been here in Stowe in this company?
We've been at this location since 1989. I've been in business since 1987. But I've been at this shop since '89, and we've expanded over the years.
And tell us a little bit about your history. Where did you learn organ building, and how did you get into the trade?
After receiving a performance degree, I went to work for various companies in New England and Lancaster County, and struck out on my own in '87 following a fire at a church where I had been doing some work which I was not responsible for, and we were commissioned then to restore the instrument, which is now still serving today.
We have seen one of your instruments recently, just a couple of weeks ago, visited St. Mary's Cathedral Road and saw that instrument. If you didn't see that video, there's a link up here where you can go watch it. You not only build new instruments, but you restore old ones as well, like this one right here. Tell us about this one.
Yes, this is E.M. Skinner 738 looking for a home. We rescued it from a church that didn't want it anymore. It's 7 ranks, and it is a fine little instrument. It is set up in our shop here at the erecting room, and if you need more information, just contact us.
Great, let's go, let's take a look around the shop.
Okay.
See a little bit of it.
All right. So when we start a project, the first thing, of course, is is a specification has been produced. The specification, of course, has to be able to physically fit the needs of the church and the available space of the client. That's real important. That's my job to come up with that. When the specification is produced, then we come up with scaling, and the scaling then produces, which is the diameter of the pipes themselves. Once we have all the diameter of the pipes themselves, then I can send everything to the engineering department, and the whole organ is basically designed on paper before we start anything. So what we have here is essentially all or many of the drawings of a specific job. Not all of the working drawings, but all of the primary principal drawings we have of the specific job. In this case, we're going to look at Grace Lutheran Church in Astoria, New York, which shows the plan view, the elevated view, and also details of the casework. And this was a very challenging project with a very limited space, and we had to produce about 14 ranks to fit into a very small attic location and produce casework for this instrument. So all of these drawings have dimensions for everything, for the casework, plan views, and whatnot, so we know where it's all going to go, how it's all going to fit, and that it is going to fit. And all the casework views for the wood shop. It takes a lot of time, a lot of effort. These are shimmer plates. We build our own winding systems and shimmer plates in-house. So that has to be all calculated out, all the winding requirements. Here we have basically is what's called a chest layout. And this essentially is we take the scales of the pipes, we lay them out on the wind chest. We saw earlier a chest grid mocked up. Once that chest grid is built, we build the toe boards. Then we take this drawing and we print it out full size, 1-to-1 scale. We take the layout template and lay it on top of the board, and if we're going to drill the toe boards by hand, we'll take the template and punch out all the center spots. If we're going to drill the toe board by CNC router, which we're going to see, that's a whole different story. It's all done on a computer, and it's merely a matter of transferring that to the CNC router computer, which center spots all the holes and drills the toe boards accordingly.
And it's not just the layout of the pipes here, you even draw the cross sections of the chest to know where the supports are going to be and how wide everything is. So everything's on paper before it ever comes out.
Nothing left to chance, because even when you do everything on paper and figure something where it's all going to go and how it's going to all go, how it's going to all work, there's always something you overlook, and usually you can overcome that because so many other things are already fixed. We're now in the engineering room, which is this nice little room with a whole lot of creative juices come out of it, and we're grateful to have Mark Tenrero here, who will show us the process it goes into with engineering and laying out our instruments, and we're going to show the process of going into preparing a tow board for our CNC router.
Well, this is the software that I use to create the part files to machine things on the CNC router. And what it's set up for now is a sample tow board based on a job we're currently working on. And it comes out of our CAD software.
And this machine's both the tow board and the rack board that holds the pipes?
Yeah, basically. The center of the pipe decides where all that stuff goes.
Okay.
And then once I get a chart with numbers for the rack board, then I can program that.
So if this were going in an organ, your layout of those holes is based on the size of the pipes and the scaling to make sure they all fit in that space?
Yeah, depending on what type of chest it is and how big the pipe is. The pipe sometimes drives the spacing, and then in other cases you've probably seen the valves and things underneath. In some cases, as you get into smaller pipes, the valve underneath becomes the larger object, and so the spacing at some point it changes from the pipes driving it to the things underneath the tow board driving the spacing.
Does the software help you with that in finding what your minimum distances is and your maximum?
Yeah, when you're dealing with the valve underneath driving things, it can be a fairly simple grid because they can only be so close to each other, so everything can get spaced up until that becomes too close for the pipes up top. Then you have to go from that, you switch gears and go up top the tow board and start spacing things from there. But once I have all those centers, the CAD software, I draw all the circles in the CAD software. Some of those circles get exported out of that software, imported into this software, and it has ways of automatically processing.
So the CNC software, it actually uses your organ designs to, you can.
Yeah, it's the transition from CAD software to CAM software. And so then when I'm done in here, I go out there and get the machine set up, get the piece in the machine, and then access the part files and run the part files, which some part files will only contain one toolpath, some part files will have multiple toolpaths contained in one file. We're limited. The machine is fairly basic. It doesn't have an automatic tool changer or things like that, so I can only run stuff that's using that one cutter at one time. But I can have multiple tool paths in that one file that are using that. As long as you're using the same cutter,
Okay.
and it'll run several things at once in its own order. This software does all that for you and creates literally, in some cases, tens of thousands of lines of code to make one little piece, and it all comes out at the other end, and I just say go,
And then
turn the machine on.
You can make the same piece over and over again without having to. If you
Yeah, once it's in the can, and there's also a templating feature that for tow boards, there's a lot of repetitive. There's only so many hole sizes that I need to bore, and for where the pipes go, the tops have to be chamfered. There's only so many depths of chamfer, and that's all driven by the size of the tow hole. So there's a templating feature in that where I can create templates based on previous jobs, plug them directly in, tell it to calculate everything, and then spit it out. Because I had already done all this work, I just started this about 5 minutes ago, and I'm ready to save out part files and send it over to the machine because the templates were already saved. I just had to make a couple of quick little changes and have it calculate it, and then I can just save it all out and send it out to the machine.
As we go through the shop today, you're going to see that we have a project going through the works from St. Francis of Assisi Cathedral in Metuchen, New Jersey. This is a 1983 sconce that we're in the process of rebuilding. And the first thing we see here is Chris Mills, a qualified technician doing pneumatic work. He's replacing several of the primary actions to one of the offset chests. So you'll see a lot of these boards all over the shop right now, and every one of them needs some degree of attention and care in the rebuilding process.
So this is all electro-pneumatic action. Has lots of little leather valves in it and leather pouches that need to be replaced. So he's replacing every single one, I would assume.
That's correct. There is a durability and life expectancy of pneumatic actions. This organ has given very fine, faithful service in a cathedral setting, and what we're doing is replacing all of the non-durable components, the leather actions, leather pouches, things like that. All the valves are being addressed as needed, and everything is now in the process of, as you can see, of being reassembled into the pouch board.
So where are we now?
We are in the heart and soul of our company, which is the wood shop. Very, very important in an organ building company to have a fully stocked wood shop. When I was an apprentice, I worked with a company that had the latest and greatest modern equipment for woodworking, and then I went to work for a company that was fully outfitted from 1920 and was poorly lit. I really enjoyed the latest and greatest stuff much, much better. It was a pleasure to work in. Good light and good equipment makes a big difference in the quality of the work you do.
Well, you've got a lot of space and a lot of modern equipment. I can see. Just from a layman's point of view, what machines do we have in here?
We have pretty much everything that a woodworker really needs. In addition to ample windows, we can see outside. All our shop is fully LED lit, so we have plenty of light. Wide joiner, planer, production sander, saw stop safety, table saw, a CNC router, panel saw, several drill presses, and then from there we go into smaller production machinery.
I see more and more organ builders bringing CNC routers into their shops. What do you mainly use it for, or what do you find it's most useful, or what it's best at?
The CNC router is something that can do a lot of repetitive operations accurately and relatively efficiently. You need an operator, you need a person who can enter the information into the computer to make the machine work properly. Once that's set to the design, you can create multiples of whatever in a very, very consistent, and consistent is the capital C word here, consistency.
So I definitely see poplar and some oak. What all kinds of wood do you usually use when construction of an organ?
That's pretty much primarily our first choice. All internal components of an organ, we use poplar, which is available domestically here in Pennsylvania. And we use a lot of white oak for casework and consoles when we're using stock components. White oak, usually if it's plain sawn or quarter sawn, we use both. That's a cabinet grade material. It takes stain very nicely, and most church furniture is usually of the white oak variety. The red oak usually has a more wild grain, but can be useful as well. If a client has a specialized need for any other species of wood, we're happy to do that. On the lesser side, we will also use walnut and maple for pedal boards. As I say, walnut is very common, and cherry.
Okay.
Beyond that, we can use anything else, but that's primarily our main palette of colors of wood and species to use.
And you generally want to match what the church already has when
Exactly.
you're bringing an organ into an existing building. So
Exactly.
either through stain or wood grain, wood type, then you can
Sure.
hopefully make an organ that looks like it always belonged there in the
Sure,
church.
sure. Because poplar we can always paint, and when you have a situation where you need to paint something, we use poplar. It takes paint very easily, and it's a hardwood. That's the key thing to use. Is that organ builders always use hardwoods, which have no knots in them, and they take sanding, they take stain or paint in an agreeable manner.
You mentioned maple for pedal boards. There's a pedal board being refurbished over here. Let's go take a look at it.
Sure. Here we have a little demonstration explanation for the cathedral in Metuchen, New Jersey, the Schanz organ, which had given many years of faithful service. Nothing shows greater the years of faithful service than these pedal keys, because you can see these holes here indicate the screw holes they used to hold the pedal keys on. These pedal keys were worn down right to the screw heads pretty extensive. You can see where they began, and over the years of playing and whatever, they've been worn down quite impressively, actually. And the same thing with the sharps. These are synthetic sharps, have a hole in them. Not supposed to be there, but that's from years and years and years and years of playing, and very well. So what we've done now is we've taken them all apart, and we have put new maple caps on all of the toe levers. after we've repainted the levers themselves, and we put new synthetic caps on top of the levers as well, retaining the compression spring and the proper screw head on it. So these are ready for many more years of service. Once they've been recovered, as you see, they're put back in the pedal board behind me, and then we use pedal weight, which is set to the proper standard for AGO weight, 3 pounds per AGO. And each key then is weighed, each spring is adjusted, so you have a consistent key weight as you go up and down the pedal board scale. So here we have the pedal board. As you can see, we've started the process of installing each pedal key. They're all numbered. They have to go in a specific order. So what basically the technician would do is they put the key weight on it, and it has to depress. If either depresses too quickly or too slowly, determines how much of the key spring, which is underneath, you have to adjust. So that one probably passed the muster, and then this is a sharp key, and then it has to go down to a certain degree. And they have to all be the same and all go down evenly, the same manner and the same distance and the same speed. So we can get a nice, even, consistent adjustment throughout all the pedal board springs. Very, very important. Organists can feel that, but we do all that adjustment here in the shop.
So over in here we build wind chests, correct?
Correct. What we have before us here is the beginning of the grade of the antiphonal chest of the Cathedral in Metuchen, New Jersey. There are some changes being made to the instrument, and specifically in this case the antiphonal, and it warranted us to simply build a new wind chest, and we're being faithful to the Chance product. We respect it highly, and so this wind chest is constructed at the same length as the old chest. We're using the same colored stain for the outside of the wind chest. The toe boards will have silver, which was standard for Chance construction of that day. And so we want it to look like it's always been there.
So talk a little bit about the chest construction. What does it take to make an electropneumatic chest? I mean, what do you have to support the pipes? How big can they get, or how big do they have to be to support all of the mechanics?
Well, the chests have to be big enough to support the mechanics and to accommodate all the pipes that are designed to go on this chest. The particular chest right here is built to hold 3 stops, and we have to have a good, solid grid, which will, as you can see, be supported from both ends, so it can't sag, okay? So it's got to be stout and sturdy in order to hold its own weight of the chest and the pipes on it. In this case, it's a grid. There'll be toe boards that go on top of it. The actions will go onto the toe boards, and on top of the toe boards will be rack boards, in which all the pipe will go into. This chest will be exposed, so you will see it from the ground. There'll be some skirting around it, some pretty decoration on it. But the pipes themselves are actually going to be functional, and they're going to be part of the visual enhancement of the cathedral, so the viewer will see them from the floor.
So are these the toe boards that will hold the pipes?
These are actually the rack boards.
Oh, rack.
Okay, these are
Oh,
the
these
rack
are
boards.
thinner, right?
They're thinner. The toe boards are going to be about 1.5 inches thick, and we'll see them in the other room. And these are the rack boards, and they still have to have center spotting put on them. But we commonly use, as you'll see, all of our toe boards, all of our rack boards, we prefer to use glued up quarter sawn wood, poplar. We find that this is much more stable with glue ups than solid lumber. Solid lumber, when you get into the excessive widths and thicknesses required, can be a little unstable, especially, yes, they can bend a little bit, because we don't really deal with old growth lumber as much anymore as we do with new growth lumber. So we try to offset that by using poplar that is run through the table saw and is quarter sawn, then it's glued up like a butcher block, because butcher blocks are very, very stable. And we make all the butcher block here in our shop, and then we find that is machines very nicely, takes grain stain very nicely, but most importantly, it's consistent and it is stable, doesn't warp and check or whatnot.
So you also have to have a bit of gasketing material to make sure that it's airtight. What do you
Right.
use to keep that sealed?
Right. In this particular project, we're using a synthetic on this chest. We use the gasketing material for where the toe board meets the grid. We'll also use a gasketing material for the lifting bottom panels to get into the action to do any kind of mechanical adjustment. We commonly use either a synthetic material or leather, and then sometimes we will use cork. The leather is our preferred method. In this case, for this chest, we're using something that was pragmatic for the rest of the instrument. All the poplar boards are ripped first, and then they are turned quarter sawn, and they're glued up. And this is an example here of us making blanks, glue-up blanks for either toe boards, rack boards, any kind of long dimensional lumber. All the boards, as you can see, are been ripped, and they're in a specific number. They have to go in the order that they came off the board. That way the board, when it kind of does its thing, it does its thing in a uniform fashion. So any kind of times you have grains that go opposite direction, that's when you have conflict. We like harmonious wavelengths in our wood. So that's what's happening here. This board is being glued up, in this case, a clamp system. We also have a vacuum press table over there that we will use to glue up larger sections of wood, especially when you have to glue up a large piece on top of it. We use a vacuum press for that, and that works out very, very well.
So you showed us how you make use of solid wood, but it is true that we use laminated wood in organ building too. A lot of people think they hear plywood and they think, oh, cheap plywood like I get at Home Depot, but that's not really what we're using. We're talking about furniture grade sort of wood, right?
That's correct. Normally you come across furniture grade, or I should say plywood, which you'll see at Home Depot. Sheathing, OSB, things like that, flake board, that's the run-of-the-mill stuff that you see that have knots on it. It just looks awful. But there are those times when you need a material in the right case, and we use a multi-ply material. The best way to just demonstrate is to look at the kind of multi-plies that are available. First you have here is MSD, and it is simply, it has its uses here and there, very limited, but it does have its use because it's very inert, very stable. And things like expression boxes, because sound doesn't go through it.
Because this is pretty dense.
Very dense stuff, right? So you wouldn't build a wind chest out of it, you wouldn't build any kind of machinery or mechanical function out of it. But when you want to build a house, you want it to be solid, stable, and inert.
Yeah, because you might need a long length of this, and that's a lot of gluing up, or a big piece of wood that might bend and warp. So yeah, you can do something like this. That makes sense.
That's correct.
So what else do we might?
Well, also you may want to look at the end grain of plywoods. I mean, here we have a veneer, a nice oak veneer, and here you'll see very wide laminates called a solid core, and it is used sometimes for casework when you have fields, wide fields, and the thing that really creates havoc with lots of solid wood casework instruments is central heating. Central heating can dry out the wood and cause a lot of checks and splits. With modern engineered materials like this, it's very stable and doesn't check. In this case, if you're going to use casework, whether you want a nice pretty veneer but don't want to check, you can have that.
And I assume if you have something, say it's a nice hardwood, you can that way you're only really paying for the veneer, but you get the strength of the interior wood without having to have a solid, thick piece of something expensive.
That's correct. That's correct. Then the other thing we want to talk about is multi-grain. Now, multi-grain, again, if you're using sometimes for very small components where you need to have some structure for which a solid piece of wood just won't it'd be practical to work with. You can use this very high quality multi-grain. You can see that the layers, the veneers, are very, very small. So there's quite a bit of glue and wood in between. You know, modern adhesives are really much better used in this application. Organ builders use primarily high glue for all of their machinery and mechanical components. But a woodworker has come a long way, and so they would use often modern adhesives, which are very, very strong, very, very dense. In this case, when you have more veneers and glue, I mean, this is a solid piece. This is as hard as a solid piece of wood. You can machine this. You can use it for structural sub-assemblies. I would not build a wind chest out of it. I would not use it for any of those critical machinery parts, but any kind of secondary components. Maybe
like the console or a stop rail or something like that.
Something that is not seen, but something that has to be rugged, stable, and useful. This can be considered for that.